How to solve Rain Man problem. Let's analyze the situation where a man on ground experiences rainfall. Say if the man is holding an umbrella and rain starts falling from the vertical direction. Certainly, his umbrella will save the man from getting wet. But what will happen if the man starts walking? To answer this correctly, we need to find the velocity of rainfall with respect to man. The velocity of raindrops with respect to man, Vrm, is given by the relation velocity of rain, Vr, minus velocity of man, Vm. Let's consider this xy frame of reference. Since the rain is falling in vertically downward in y direction, let's say Vr vector. And man is moving towards the right along x direction with velocity Vm. So minus Vm vector would be in minus x direction. Resultant of the two vectors will be in the direction of the velocity of raindrops with respect to man. This means that the man will observe that the rain is falling at an angle theta from the vertical, where tan theta can be calculated as the ratio of magnitude Vm and Vr. So while walking, if man is holding the umbrella in vertical direction and raindrops are hitting at an angle theta with the vertical direction, then obviously the man will get wet. So in order to save himself from getting wet, he has to hold the umbrella in the direction of raindrops with respect to man. All of us hold our umbrellas similarly at an angle to avoid getting wet intuitively without caring about the physics behind this. Let's solve an example to understand this concept better. Question: a man is standing on ground with an umbrella hat as shown in the figure. Suddenly, rainfall starts at speed Vr equal to 20 meters per second at an angle 30 degrees with the vertical. Find the speed and direction in which man should start running so as to save himself from getting wet. Solution: in the question, we are given that the man is wearing an umbrella hat. We can safely assume that this umbrella hat is very small in size and it can only save the man if the rain is falling vertically downwards. But we are given that the rain is falling in the direction at angle theta equal to 30 degrees with the vertical. So this umbrella hat will not be able to save the man from getting wet. Therefore, the man should run in such a way that velocity of rain with respect to man should be in vertically downward direction. Then only his umbrella hat will be able to save him. Velocity of rain with respect to man, Vrm, is equal to Vr minus Vm. We are required to find the value of Vm. We are given that Vr is in the direction at an angle 30 degrees with vertical and the value of Vr is 20 meters per second. If Vrm is in vertically downward direction, then minus Vrm will be in vertically upward direction. So resultant will be towards left, which is the velocity of man. So man has to run towards left with the velocity of Vm, and the magnitude of Vm can be found from this triangle. Vm equal to Vr sine theta. Putting the value of Vr and sine 30 degree gives us the velocity of man equal to 10 meters per second. Thus, if the man runs with a velocity of 10 meters per second in the left direction, the umbrella hat will save him from getting wet. Thanks for watching. Please like, share and comment on this video.